Find I1 and I2 in the circuit in figure. Here we can see this is a two-port network and we have to find I1 and I2 of this two-port network. As we can see, the Z parameters for this two-port network is given. So, solution. First we will write the expression for Z parameter. The expression for Z parameter is V1 is equal to Z11 I1 plus Z12 I2 and V2 is equal to Z21 I1 plus Z22 I2. Suppose this is equation number 1 and this is equation number 2. Now, here we can see the value for Z parameter is given. Also, the value for V1 is given. Then we can find the value of V2. Here we can see V2 is equal to voltage is equal to current into resistance. So, the value for resistance is 10 and the value for current is I2. But here we can see the direction of this I2 is opposite to the polarity of this voltage V2. So, here this will be minus. So, therefore, V2 is equal to minus 10 I2. Now, we have the value for V2, we have the value for V1, we have the value for Z parameters. So, we will substitute these values in this expression. So, here V1 is equal to 100 at an angle 0 degree. So, 100 at an angle of 0 degree is equal to Z11. The value for Z11 is 40 ohm. So, 40 multiplied by I1 plus Z12. Z12 is J20 ohm. So, J20 into I2. Now, here V2 and V2 is equal to minus 10 I2. So, minus 10 I2 is equal to Z21. Z21 is J30. J30 I1 plus Z22. Z22 is 50 ohm. So, this will be 50 I2. Now, we will simplify this. So, this will be, if we take this minus 10 I2 on right side, so this will be J30, this J30 I1 as it is, then plus 50 I2 as it is, then this will be plus 10 I2 is equal to 0. Now, if we simplify this, so this will be this J30 I1 as it is, then this will be 50 plus 10, 60 I2 is equal to 0. Now, if we take this 60 I2 on right side, so this will be J30 I1 is equal to minus 60 I2. And this will be I2 is equal to minus J30 divided by 60 and this I1 as it is. Now, this will be I2 is equal to minus J and this will be 1 by 2 or 0.5 I1. So, this is the value for I2. Next, this equation, let's say this is equation number 3 and this is equation number 4. So, now we will solve equation number 3. So, from equation number 3, if we substitute I2 is equal to this value, then this will be 100 at an angle of 0 degree is equal to 40 I1 plus J20. The value for I2 is minus J 0.5 I1. Now, this will be 100 at an angle of 0 degree is equal to 40 I1 plus, now this will be J into minus J. So, in calci complex mode, this I into, or we will substitute all value. So, this will be I into 20 multiplied by minus I into 0.5. So, this will be 10. So, 10 I1 And now this will be 100 at an angle of 0 degree is equal to 50. 40 plus 10, 50 I1. So therefore, I1 is equal to 100 at an angle of 0 degree divided by 50. So this will be 2 at an angle of 0 degree ampere, because it is current. So the unit of current is ampere. So I1 is equal to 2 at an angle 0 degree ampere. Now from I1 we can find the value of I2, since I2 is equal to minus j 0.5 I1. So we will substitute the value of I1 here. So this will be minus j 0.5 multiplied by 2 at an angle of 0 degree. Now in calci, if we solve this, so minus I multiplied by 0.5, minus I multiplied by 0.5, then multiplied by, in bracket, 2 at an angle of 0 degree. So this will be minus j. So minus j, this is in rectangular form. I2 is equal to minus j ampere, or in polar form we can write I2 is equal to, if we convert this minus I in polar form, then shift 2, then 3. So this will be 1 at an angle of minus 90 degree, 1 at an angle of minus 90 degree ampere. This is the value for I2. What we have to find? We have to find I1 and I2 in the circuit in figure. So here in this circuit we have to find I1 and I2. So the value for I1 and I2 is, I1 is equal to 2 at an angle of 0 degree ampere, and I2 is equal to 1 at an angle of minus 90 degree ampere. So this is the final answer.